Hello everyone, I'm Dr. Monica. Today in this video, we'll learn more about cementum and its various classification. So let's begin. Starting with the definition, according to Carranza, cementum is the calcified avascular mesenchymal tissue that forms the outer covering of the anatomic root. Calcified meaning that it is a mineralized tissue, avascular meaning that it does not have its own blood supply, and mesenchymal tissue meaning that it is derived from specialized stem cells. Cementum is a Latin word which is derived from cementum, meaning small rough stone-like structure. It is a crucial component of periodontium. Historically, cementum was first discovered by Frankel and Raskow in 1835, and later Anders Adolf Retzius further identified and studied it in 1837. Cementum is bone-like tissue covering the tooth's root, but unlike bone, it is avascular, meaning that it does not have its own blood vessel. It does not undergo dynamic remodeling like the bone, that is, it does not reshape itself in response to stress. Its unique characteristic is that it increases in thickness throughout life, especially in the apical region, helping to maintain the tooth stability and attachment. Let's talk about the physical characteristics of cementum. First one is the hardness. Cementum is less hard than dentine. Coming to color, cementum it is light yellow in color and it has a darker hue as compared to enamel. It lacks lustre, meaning that it has a dull appearance. Coming to surface texture, cementum shows a mosaic pattern referring to its irregular layered deposition over time, which creates a patchwork appearance due to its non-uniform mineralization. Coming to permeability, cementum is more permeable than dentine. The last one is the thickness. Cementum at the coronal half is 16 to 16 microns thick, whereas at the apical third and furcation area, it is 150 to 200 microns thick. It is thicker on the distal aspect as compared to mesial surfaces, whereas it is thinnest at the cemento-enamel junction. Chemical composition of cementum reveals that it is more organic than inorganic. Cementum is made up of 45 to 50% inorganic content, primarily composed of calcium and phosphates, which form hydroxyapatite crystals. It also contains trace elements with highest fluoride content. Now moving to organic content, which makes up of 50 to 55% of cementum. This consists mainly of type 1 collagen, which provides structural integrity, along with proteoglycans and polysaccharides, which help in maintaining extracellular matrix. Now let's discuss the three essential functions of cementum. First is the anchorage. Cementum plays a key role in providing firm attachment site for the PDL fiber, which connect the tooth to the alveolar bone. Second function is adaptation. Cementum adapts to functional needs, that is, during tooth wear or eruption, new cementum is deposited at an apical area to compensate for the loss of tooth substance. Last function is repair. When root surface is damaged due to fracture or resorption, new cementum is deposited to restore the lost structure. Now let's talk about the cementum forming cells, that is the cementoblast and cementocytes. Firstly, talking about cementoblasts, these are large cuboid cells with round euchromatin rich nucleus. They originate from the mesenchymal cells of the dental follicle. They synthesize collagen and the non-collagenous proteins. Next we have cementocytes. These are entrapped cementoblast cells with reduced secretory activity. These reside in lacunae. Cementocytes in the deeper layers are not vital and they lack a vascular system. Talking about the types of cementum, we have two types, that is coronal and radicular. Coronal cementum, they are found on the anatomic crown where it covers the enamel as seen in the herbivores. In case of humans, it is restricted to areas of reduced enamel epithelium. Whereas in radicular cementum, it is derived from dental follicle. It covers the entire dentine of the root from CEJ to the root apex, and it extends partially into the apical foramen to line the apical walls of the root canal. Now let's explore the classification of cementum. Cementum can be classified on the basis of presence or absence of cells, time of formation, location, presence or absence of fibers, origin of fibers, and lastly the Schroeder's classification. Based on the presence and absence of cells, cementum can be classified into acellular and cellular cementum. Talking about this acellular cementum, it is found on the cervical third of the tooth, whereas cellular cementum, it is seen mainly at the apical third and interradicular area. Talking about the embedded cementocytes, these are absent in the acellular cementum, whereas they are present in the cellular cementum. The deposition rate is slower in the acellular cementum compared to cellular cementum. Acellular cementum, it is the first formed layer, whereas cellular cementum, it is formed after the formation of acellular cementum. The width of acellular cementum is more or less constant, whereas it is highly variable in the cellular cementum. Sharpest fiber, they are going to be well mineralized in the acellular cementum, whereas they are partially mineralized in the cellular cementum. Incremental lines, they are regular and closely packed in the acellular cementum, whereas they are irregular and they are placed wide apart in the cellular cementum. Based on the time of formation, we have primary cementum, which is formed before tooth eruption, and we have secondary cementum, which is formed after tooth eruption. Based on location, we have radicular cementum, which is found on the root surface. Then we have the coronal cementum, which is formed on the enamel, which covers the crown. Based on the presence or absence of fibers, we have fibrillar cementum. In this cementum has a matrix which contains well-defined fibrils of type 1 collagen. Then we have afibrillar cementum. In this cementum has a matrix devoid of type 1 collagen fibrils. Instead, the matrix have a fine granular consistency. Based on the origin of fibers, we have extrinsic and intrinsic fibers. Extrinsic fibers, they are formed by fibroblast and partly by cementoblast, whereas intrinsic fibers, they are derived from cementoblast. Extrinsic fibers, they run in the same direction of the periodontal ligament principal fibers, that is perpendicular or oblique to the root surface, whereas intrinsic fibers, they run parallel to the root surface at right angles to the extrinsic fibers. Extrinsic fibers, they are partially mineralized with unmineralized core, whereas we can see uniform mineralization in the intrinsic fibers. Schroeder and Page classified cementum on basis of location, morphology, histologic appearance, function, rate of formation, biochemical composition, and degree of mineralization in the year 1986. The five types of cementum classified by Schroeder and Page are acellular afibrillar cementum, acellular extrinsic fiber cementum, cellular intrinsic fiber cementum, cellular mixed stratified cementum, and intermediate cementum. Let's discuss one by one all the types of cementum, starting with the acellular afibrillar cementum. Acellular means that it does not contain any cells, whereas afibrillar means that it does not contain any extrinsic or intrinsic collagen fibers. It is formed by cementoblast and found at the dentino-enamel junction as a coronal cementum with a thickness of 1 to 15 microns. It is formed as an aberration of the development process and appears as cemental spurs or cementum island on the crown of newly erupted teeth. It is of less functional value as it is not involved in any fiber insertion or anchorage. Let's talk about the acellular extrinsic fiber cementum. Acellular means that it contains no cells. Extrinsic fiber means that it contains the extrinsic fibers. There are no cementocytes present. It is formed by fibroblast and cementoblast. The Sharpey's fibers, they are continuous with the periodontal ligament fibers, and the fiber increase in thickness with age. This type, it is present around cervical margin of the tooth and covers the two-thirds of the root. In the single-rooted teeth, they extend till apical foramen. The main function is in the tooth anchorage through Sharpey's fibers. Talking about the cellular intrinsic fiber cementum. Cellular means that it contains cells. Intrinsic fiber means that it has intrinsic fibers. It is formed by cementoblast and it is less mineralized than the AEFC. We can see cementocytes enclosed in the lacunae, and this is also found at the fracture sites. It mainly covers the apical third and the interradicular regions of the premolars and molars. Main function is in repair and adaptation. Let's talk about cellular mixed stratified cementum. Cellular means that it contains cells, and mixed stratified means that it is composed of Sharpey's fibers and intrinsic fibers. It is mainly present in the apical third and the interradicular region of premolars and molars with 100 to 1000 microns thickness. Main function is in the root anchorage and adaptation. Talking about the last type of cementum, that is intermediate cementum. It is also known as the hyaline layer of Hopwell-Smith due to its structureless appearance. It is a poorly defined zone near the cemento-dentinal junction separating the cementum from dentine. It is dentinal in origin with no dentinal tubules present. Her cells become trapped in a rapidly deposited dentine or cementum matrix, giving rise to intermediate cementum. It shows no characteristic feature of either cementum or dentine. It is present in the apical two-thirds of premolars and molars.